We're going to step away from the Earth for a little bit and talk about, in my view, in some view, the most important object in the solar system besides the one we live on, but the one at the center of it, the sun, the thing that powers it all. So let's start off with the sun we see every day is not too exciting. I mean, we know that we're not supposed to look at it. It's really, really bright. But even if you look at it with a telescope and look at it in visible light, unless there's a sunspot, too loud? Too loud? Okay, can you turn it down just a little bit? Unless you look at it outside of the atmosphere, it's really just a big yellow ball, maybe with a sunspot or two across it. But if I step out into space and look at the sun with a telescope that sees wavelengths that I can't see with my own eye, this is what I see. This is the sun in extreme ultraviolet seen from the Solar Dynamics Observatory. And you can see it's so much more dynamic. We have a huge explosion here. This is billions of tons of solar material blasting away from the Earth at millions of miles an hour, called a coronal mass ejection, filling the entire solar system. We have a flash of light through the entire electromagnetic spectrum, from radio all the way to gamma rays, with enough power, enough energy to power the world for 100,000 years. That's called a solar flare. And both of those huge eruptions create massive shock waves that accelerate particles at near the speed of light. And all of this stuff fills the solar system and interacts with everything in it, with planets, with their atmospheres, with their magnetic fields if they have them, with asteroids and comets, but also with the things and the people that we put into space, with our spacecraft, with our astronauts. And so we want to be able to understand this, maybe even predict it, and have something similar to terrestrial weather. We actually call it space weather. But we want to be able to protect our assets and protect the people as we send them back to the moon and beyond to Mars. And because we have a new initiative now, a new program, Artemis, to go back to the moon, to send the next man and the first woman to step foot on the lunar surface, we have a unique opportunity. We can now do unique science from the moon, and in particular, unique science to understand this beast sitting at the beginning of in the center of our solar system, and understand better the influence that it has on us, and protect those people that we're sending to the moon and to Mars. So next slide, please. This is actually a really nice observation. So here is the same spacecraft, a different wavelength, but extreme ultraviolet. But look, you see this object move in front of it. Okay, that's the moon. That's the moon basically eclipsing the sun. We're seeing this from space. And in fact, we can use this opportunity to learn things about the moon itself. These images are so detailed that when you see that shadow come past, what you're actually seeing is, if you look at the bottom, it's not smooth right here. There are little bumps on it. You're actually seeing the you're seeing the mountains of the moon when you look at this edge. So using a solar telescope, we're actually learning something about the moon, but we can turn this around because the moon gives us a unique perspective. Next slide, please. We have a unique opportunity because sitting on the surface of the moon, we have no atmosphere, okay, giving us the ability to observe these wavelengths of light that we can't see from the ground on the Earth because they're stopped by our atmosphere. Those extreme ultraviolet or gamma rays or X-rays. And also, the moon does not have a magnetic field. Because not only do we see the light coming from the sun, all of those particles, when they get to the Earth, are affected by the magnetic field of the Earth. They actually create a very interesting, complicated environment. For example, creating the Van Allen radiation belts, which we have to deal with as we fly through them away from the Earth. So sitting on this object orbiting the Earth, we have a unique platform for us to observe the sun and to observe the environment around the sun. We can look at those huge blobs of material, coronal mass ejections, leaving the sun. We can study the particles as they're reaching the Earth, as they pass by the moon. So if you go to the next slide, please. So what you're looking at here is the same explosion that I showed you at the very beginning. And we're going to back away from that so you can see what happens when that object, those particles, leave the sun. We have this background of particles called the solar wind that's always flowing away from the sun. And then on top of that, you have this bigger cluster of particles, that coronal mass ejection, traveling from the sun through the solar system and eventually interacting with objects in the solar system. Here we see it passing Venus. And you'll notice the particles are actually impinging the atmosphere of Venus directly because Venus doesn't have a magnetic field. So they're moving straight, impacting the atmosphere, creating a unique environment. And as they continue on and eventually reach the Earth, now you see the particles are actually moving around it. Okay? Because the Earth's magnetic field is acting as a sort of force field, protecting to somewhat the Earth, creating a very interesting and complicated environment. So when we sit on the moon, we don't have those aspects. We don't have the atmosphere. We don't have the magnetic fields. But there are a couple of things that are unique about that environment. Let's go to the next slide. Let's actually skip ahead. I want to pass this one and just skip to this. So that magnetic field of the Earth, and we're, in this case, the sun is in this direction. As it's coming, as all those particles are coming past us, they're stretching the magnetic field of the Earth, creating this sort of elongated, almost tadpole-like structure. We call this the magnetosphere. There are particles around it, particles building up along the back part. This is an incredibly complicated environment that our spacecraft and the ISS is traveling through. But also, in order to understand this, we have a unique perspective with the moon because, in fact, the moon, as it's orbiting the Earth, it's actually passing in and out of this structure. During the new moon, when the sun is over there and the moon is directly on the other side of the Earth, it's actually sitting right in here. So for about 6 days, the moon orbits through the magnetosphere and allows us to sample what's happening in this unique environment. And as the moon moves around it, we sample different parts of this whole structure. We see different characteristics, different environments. And eventually, for a full moon, it's sitting over on this side, almost completely out of what we call the magnetosphere. So we have this observing platform, this natural observing platform that's moving around the magnetosphere, allowing us to sample this hazardous, complicated space that we have to travel through, to measure the particles, to measure the electric and magnetic fields, to measure the plasma created in this whole structure. And then at the same time, we're able to get a unique view of what's happening coming from the sun as we are orbiting, moving with the moon as it's orbiting the Earth. Because again, we have no atmosphere, so now we can have very large, powerful telescopes that we don't have to put into a spacecraft. We can actually have on the body itself to allow us to study all that's happening from the sun in multiple wavelengths of light measuring different types of particles, different types of electric and magnetic fields, structures, to ultimately understand this very complicated environment that we have to travel through and that we have to ultimately live in as we bring people to the moon and someday on to Mars. So the moon is providing something for us that is unique and exciting to allow us to understand the environment created by the sun. And as we understand that, not only do we get a better handle on how to deal with it, how to live with it, how to travel through it, but what we learn about our own sun ultimately tells us about other stars, other solar systems, and the planets and bodies that are interacting with them. So we're looking forward to 2024 and beyond as we start to explore this new, unique environment to study our star and ultimately put other kinds of telescopes, other kinds of instruments to study other stars, other aspects of not just our solar system, but the universe. So thank you very much.